Good day wherever you are. My name is Teacher David. I want to take you through Chemistry Paper 3 Kcse 2026 revision. So let's look at this question. You're provided with 0.2 molar hydrochloric acid solution P, 5.3 grams of metal carbonate T, 5.3 grams of metal carbonate T2 carbonate dissolved in water to form 500 centimeters cube of solution Q. So first I want to show you that the metal carbonate it is a monovariant. Why is it a monovariant? So the carbonate could be something like potassium or sodium or lithium. Why? Because this one has a valence of 1. When the carbonate is reacting with it, it will put the 2 here. Otherwise, if it was a divariant, it could only be T carbonate. Because if it has, this one has I was demonstrating that metal T is a monovariant. Monovariant meaning it has a valence of 1. That's why K, like potassium, it is likely to be potassium or lithium, because this one has a valence of 1. The carbonate has a valence of 2. So when it is crossing, it puts the 2 here. That's why it is. If it was a divariant like sodium, like magnesium, like calcium, then it could be like this without the 2 here, because each of them has got a valence of 2 and it cancels out. So when you are told a monovariant or divariant, you should be able to understand that. Another thing I want you to mark is that the 5.3 grams was dissolved to form a solution of 500 grams. Very important. Keep that in the back of your mind. Let's look at the procedure. Fill the purate with hydrochloric acid solution P. So the purate contains the HCl. Then we are going to pipette 25 of solution Q, which is the metal carbonate, into a conical flask. Then we will add methyl orange, titrate until it is permanent pink. Then we shall record our readings in the table below. So I have given the initial, so I have given the final purate reading. I initial because you can see I have started with 1 decimal place, so just put initial to be 0.0 to 1 decimal place. Because the decimal place must be consistent, then subtract 23.0 minus this, the answer is 23.0. 23.2. The calculated average volume of solution P. Average volume. For you to calculate, you need to look at the values you have, the 3 values. Are the 3 values in the range of 0.2 plus or minus? Are they in that range? If they are in that range, then you can do the average with all of them. But when you look at this one, this is 22. When you look at this one, 23.2, 23.0 is within this range, but this one is outside that range. Therefore, when you do the average, if you do the average with a 3, you will lose 1 mark for accuracy. Therefore, having that in mind, then the average will be done with only 2. We will do 23 plus 23.2 divided by 2. That one will give you the average and you will get this 1 mark. But if you do the average with a 3, because this one is outside, 22.1 to 23.3 is a long value. There are so many values inside there. Therefore, you will get the average as 23.10 centimeters cube. We add this 0 to balance 2 decimal places as required for the average. Write the chemical equation for the reaction that took place. Write the equation for the reaction. Remember now it is T carbonate. So T carbonate that is reacting with HCl a carbonate with HCl will form the T salt, T chloride, plus water or plus CO2 plus water plus water. Then you need to balance the equation. As you can see, T has 2, so it has to be 2. You put 2 here to make it balance, to balance it. Once you balance it, this one, it enables you to put another 2 there for it to be balanced. That equation now is balanced. Status you can write if you want. So this is a solid. This one was in aqueous. Aqueous, you can write the status if you want. Calculate the number of moles of solution B in the average titer solution B. So number of moles, where do you begin? You go back to what you are provided with. You are provided with 0.2 molar hydrochloric acid solution P. So this is the number of moles in 1,000, because this is a molarity. Capital M stands for molarity, and molarity is the number of moles in a liter. So you come back here and say 0.2 capital M. Capital M means molarity, and this implies that 0.2 is the number of moles. 0.2 is the number of moles in 1,000 centimeters cube of solution P. How much volume of P we used? We used 23.1. So you come here and ask 23.1 centimeters cube, the one we used, solution P, will contain how many moles? That will be 23.1 times 0.2, you divide by 1,000. And the number of moles will be 0.00462. That is the number of moles. The number of moles of the carbonate in 25 solution Q, the number of moles. Now here, the reason why we wrote this equation, it is to help us with the mole ratio. You can see that 1 reacted with 2. So 1 mole reacted with 2 moles of HCl. Now we know the number of moles of P, which is HCl. Automatically we will know this one because of the ratio. So we say since the mole ratio T2 carbonate to HCl solution P is 1 to 2, then moles of T2 carbonate is actually a half of that of HCl. Is a half the moles of HCl. Therefore, the moles will be a half times 0.00462, and that one is 0.0023231. Yes. Calculate the number of the molarity of Q in moles per liter. Q, remember, it is the carbonate, the T carbonate. Now we have calculated the number of moles of T carbonate in 25. Molarity is the number of moles in a liter. So a liter is equal to 1,000 centimeters cube. Therefore, you will say from Roman 2, 25 centimeters cube of Q contains 0.00231 moles. We will simply ask 1,000 centimeters cube of solution Q will contain how many moles, because molarity is the number of moles in a liter. We have the number of moles of 25 solution Q that reacted with the P, HCl. Now we can equate and get that. So this is 1000 times this divided by this. 0.00231 times 1000. You divide by 25. It gives you the number of moles in, or the molarity in a liter. That one is 0.0924 capital M. That is the molarity of solution Q, the carbonate, right? The concentrations of Q in grams per liter. The concentration of Q in grams per liter. In other one, they are asking you to calculate the mass in grams per liter. Remember now, go back to what you are provided. We were given the mass of Q, in 500. Now we want the mass in a liter, grams per liter. So we know the mass in 500. A liter is 1000. So we'll say this is in 500. What about 1000? So 500 centimeters cube of Q contains 5.3 grams. A liter will contain of Q will contain how many? That's 1000 times 5.3 divided by 500, and that one will be 10.6 grams per liter, and that is what we wanted to calculate mass in grams per liter. The relative formula mass, RFM. RFM, use the triangle. To calculate the RFM of a given substance, you use this formula. Molarity, mass in grams per liter, RFM. So if you have the mass in grams per liter of that substance, you have the molarity, RFM is simply very simple. Now we have the mass in grams per liter of the carbonate Q. We have the molarity of Q, this one. Now RFM is simple. So you write RFM is equal to mass in grams per liter divided by molarity. You will hold the formula here, mass over this. If you wanted molarity and you have this, molarity is equal to mass over RFM. If you wanted mass in grams per liter, it is molarity times RFM. So mass in grams, that is 10.6. You divide by molarity 0.0924. So this one, it gives us 114. So you can round off to 115 to get the whole number, 115. Calculate the relative atomic mass of metal T. They calculate the relative atomic mass of metal T. Now we have been given carbon is this and this. So it means the T2 carbonate will be equal to the RFM, which is 115. So T, there are two of them. You plus carbon, which is 12, plus 16 times 3 will be equal to 115. 2T plus this is 60 is equal to 150. Bring like terms together. 2T will be equal to 115 minus 60. 2T will be equal to 55. Now we want T divided by 2 both sides. Therefore T is equal to 27.5, which is the same as 28. Therefore the RAM of T is equal to 28. RAM of that metal is equal to 28. Thank you very much. If the video is good to you, please share like, and comment. What do you comment? You say good work, improve, do this, and do that. That's what you comment. It doesn't cost anything so long as you are online. It doesn't take more credit. You only say improve here, add the volume, reduce the volume. Make sure next time you do this, you like, then you comment. That is the comment we want. You don't need to say anything more than that. Thank you. You are provided with solid N. Carry out the test below. Write your observations and inferences in the spaces provided. Heat about a half of solid N in a clean dry test tube. Heat gently, then strongly. Test N gas produced using moist, blue, and red litmus paper. That is a common test. You need to ignore observation that is expected. A colorless liquid is formed. It is always expected that a colorless liquid is going to be formed at the cooler parts of the test tube. Do not say water is formed. Who told you this water? Don't say the test tube sweats. If that is not chemistry. So simply master this, that a colorless liquid is formed. That is what we expect. What happens to the blue litmus paper? It is either the blue litmus paper will change to red or it will remain blue. Red will change to blue or it will remain. So in this case, so it depends the salt provided. Blue litmus paper changes to red while red remains red. So what is that changes blue litmus paper to red? Then it must be that the gas that was produced is acidic, because blue litmus paper changes to red in acidic solution. So for this one, you write, if it contains what this one, a colorless liquid is formed, then it means it contains water of crystallization. Just say hydrated salt in the inference. Hydrated substance or salt. Hydrated substance present. Or you can simply say solid N is hydrated. Solid N is hydrated or contains water of crystallization. Solid N contains water of crystallization. Contains water of crystallization. On the blue litmus paper turning red or changing to red, it means it contains hydrogen ions present. Hydrogen ions present. Take a spatula end of N in a test tube and add distilled water until a half filled. Shake, divide the solution into 5 portions. So the solid dissolves, forming a colorless solution. So if a colorless solution is formed, then it means the colored ions are absent, because those that dissolve to form a colorless solution are very many. So we write what is absent. So for this one, copper 2 ions is absent because this one is blue. Ion 2 is absent. Why? Because this one is green. And ion 3 is absent because it is brown. Absent. So you write this is absent because it is colorless. This is blue, green, brown. To the first portion, add 2 molar sodium hydroxide solution. Drop white until in excess. The observation are a white precipitate is formed, which dissolve in excess sodium hydroxide to form a colorless solution. So sodium hydroxide will dissolve in the amphoteric ions only. So the amphoteric ions, we have them, we call them ZAP. ZAP stands for zinc, aluminium, and lead. These are the amphoteric ions. Therefore, sodium hydroxide dissolve here only to form a colorless solution in excess. So there you write zinc, standing for sub, Z, aluminium, 3 positive, and then lead. So these ones are present. The word present and absent is very important in this case. To the second portion, add 2 molars ammonium hydroxide or ammonia solution. A white precipitate is formed which dissolve in excess. If it dissolves in excess to form a colorless solution, then it means what is present is zinc. So due to this observation, then the zinc 2 ions are present or confirmed, meaning aluminium and lead are absent. To the third portion, add 3 drops of 2 molar HCl. So if you add HCl and lead was inside there, it will form a white precipitate, which is lead chloride. Lead chloride is a white precipitate. Now, since there is no white PPT, it means lead is absent because HCl, Cl will combine, was expected to combine with lead. But now that there is no white precipitate, it means it is absent. So for inference, you just write lead 2 ions absent, because already we have confirmed what is present. To the fourth portion, add about 1 centimeters cube of 2 molar lead nitrate. Lead, a white PPT is formed. So lead forms a white precipitate with the carbonate, so that we have lead carbonate, because we know all carbonates are insoluble, are white precipitate except that of potassium, sodium, and ammonium. It will also form a white precipitate with a sulfate, because we know lead sulfate is a white precipitate, a sulfite, and a chloride, because lead chloride is a white precipitate. All chlorides are soluble except lead chloride and silver chloride. So from that, because a white PPT is formed, it means the sulfate, the sulfite, the carbonate, and the chloride are present. That is what it means. To the fifth portion, add 1 centimeter of 2 molar barium nitrate followed by dilute nitric acid. Now this one is supposed to help us to distinguish, to eliminate some of the anions present. A white PPT is formed which is insoluble in the acid. If a white precipitate is formed, if you add nitric acid, it dissolves to form a colorless solution. It means it is the sulfite and the carbonate present. But if you add barium, it forms a white PPT. Then in addition, when you add dilute nitric acid or HCl and the acid, when you add the acid, the white precipitate persists. It means what is there is the sulfate. So you say SO4 2 minus confirmed or present. You can say present or confirmed. That is what is there. Thank you.